Hey everyone, let's go ahead and look at lesson 8.3. We are talking about exponential growth and decay with some real world examples. We also want to make sure that we understand that the value of b, which is just beneath that variable x, can actually be written as two different values, which is the 1 value and the r value. 1 represents 100% and r represents any other percentage that they are adding or subtracting from that 100%. Okay? So we have to make sure that we understand how to turn a decimal into a percent and a percent into a decimal. In order to do that, if you have a percent, so let's say that I have 75%, and I want to convert that into a decimal, I am going to divide by 100. So then that will give me 0.75. Now, if I had a decimal that was already written, let's just use 32.5, but I want to turn that into a percent, then what I'm going to do is multiply that to 100. Okay? And then that would give me 33,250%. I know that sounds absurd as a percent, but those are just numbers that I randomly picked out of my head. Okay, so when we were writing these, the A value is the initial value, our starting value. R is the percent rate of change, the percent that they give us. B is still that definition of a growth or a decay factor, and X will represent time. We haven't inserted a time yet, except for on very few occasions, like the extra credit. So just keep that in mind that X will represent time as we're going forward. All right, here's some information that I've laid out when it comes to what is y equals ab to the x when we are dealing with a percent rate. So that is there for your reference to go back and look at as you need to. Now notice though that whenever we are talking about a growth, we are going to have 1 plus another percent. When we are talking about a decay, we will have 1 minus a given percent. All right, let's go ahead and look at some equations here. First off, number 1, we still have an A value, we still have a B value, but B is made up of 2 combined values, and it is made up of 1 and the R value. The R is that common percent rate. Okay? So let's first start off. What is our A? A is -6. What is the R value? Well, the R, when I'm looking at this equation over here, let me erase that really quickly. The R value is right after 1 plus or 1 minus. Okay? And again, that R value is a decimal, but it does represent a percent. So in this case, the R value is 0.6. And since percents are not negative, the decimal form of that percentage is also not negative. So 0.6 represents or is equivalent to 60%. Now, when I add those two together, 1 plus 0.6, that gives me 1.6. That's my B value. That's greater than 1, so that is going to be a growth. Okay? All right, number 2. On number 2, the A value is 300. The R value is 0.35. Now again, even though it's minus 0.3, the R value itself, the common rate or that common percent will never be a negative number. So 0.35 written as a percent will be 35%. Now when I combine them together, 1 minus 0.35, I get 0 and 65 hundredths. And because 0.65 or 0 and 65 hundredths is between 0 and 1, this one is a decay. All right, let's look at number 3. Now on number 3, I know that it's fractions, so don't freak out on the fact that it's a fraction. If you want, you can convert this into a decimal. So I have g of x is equal to 1 over 3. I'm going to go ahead and leave that one a fraction because otherwise it would give me a weird decimal or an ongoing decimal. 1 divided by 5 is 0.2 to the power of x. Now, you can choose to use the one that is as a fraction or the one that's as a decimal. For the video's sake, I'm going to use the one that's as a decimal. Our a value is 1 over 3. Now, if you notice, there's only one number here inside the parentheses. That's because they've already put 1 plus r or 1 minus r, and they've already combined them to give me the b value. So our b value is 0.2. So how do we find that r value? So if it was 1 plus something equals 0.2, now what we're going to do, and that something is, excuse me, let me change that something to r, to the variable r. But hold on one second. One plus r equals 0.2, or 1 minus r equals 0.2. And in this case, because 1/5 is smaller, I know that it's 1 minus r equals 0.2. Okay? Now, when I take this positive 1 and move it to the other side, it becomes a negative 1. Then when I divide everything by negative r, so if I divide this by negative 1, divide this by negative 1, divide this by negative 1, I get r is equal to 0.2. Sorry, negative 0.2 plus 1. And that's really r is equal to 1 minus 0.2. So that's really what's happening here. But let me show you this formula that we talked about in class that does this exact same thing. We said whenever they give us A and they give us B, here's what we're going to do. We are going to take the B value minus 1, and that will equal R. Okay. So B minus 1 is equal to 0.8. Now here, if I had R and I did 1 minus 0.2, that is 0.8. Okay. Now I know that this one up here is negative 0.8. That negative just means that it's a decay, and the 0.8 is the R value. Also can be written as 80%. All right, so let me erase that and just show you really quickly what I did. So I was given the initial value. I was given B. And now I take B minus 1 to find R. So 0.2 minus 1 equals negative 0.8. Do you have your pencil? Can I borrow your pencil? Mine's not charged. Now the negative makes it a decay, and 0.8 is the rate. Okay. All right, so right here, what I would suggest that you do is pause the video, go to the back side of the paper, and complete these three. Okay. All right, so let's go on to this next part when we have real word problems. Okay. So when I have these word problems, sometimes they give us a percentage, and sometimes they give us keywords that represent the B value. So if I have half-life here, so if I said half-life, how would you think of writing half in math? Well, that would just be B equals 1/2, or we could say B equals 0.5. Okay? Now doubled, in math, doubled means that we multiply by 2. Tripled, B would be multiplied by 3. Okay? So we're looking for those keywords, or we're looking for a percent that is part of B. So a scientist observed a culture of bacteria that initially contained 50 cells. I know that initially part is my A value. The bacteria population doubled every hour. That's the B value. Write an equation to represent the relationship of the number of bacteria over time. So they gave me A and B, but they did not give me R. So I can easily write this equation. Because the B value of 2 is greater than 1, then I know this is a growth. Okay. Now, sometimes they won't give me half-life doubled or tripled. Instead, they'll give me a percent. So when they do, we're going to go ahead and look at example 5 and see what we would do there. Detroit, Michigan has experienced a loss in population. Loss tells me that this is a decay at a rate of 5.78%. That's the R value. So when we write that as the R value, remember that we have to divide that by 100 so that we can convert that to decimal form. Each year. In 2020, the population was 639,111. That's the initial value. Now, the year 2020 is a number, but we're not talking about years. We're talking about population. So the year 2020 doesn't matter to me right now. It's just when they started with this survey. Now, to find B, we have to do 1 plus R or 1 minus R. Because it's a decay, we're going to do 1 minus the R value. Okay. So when we write the equation, we have Y equals 639,111 times B. When I subtract these two, because I want to conjoin them together, I get 0.9422 to the power of X. Okay. All right, so when you're on the back side of this worksheet, you have D, E, F, and G that you're working on. Look for something that says doubled, tripled, or half-life, or if they don't give you that information, look for a percent. So A talks about where did we start? What's our initial value? R is the percent as a decimal. And B is the growth or decay factor. All right, so on letter D, let's consider whether we can find A, R, and B. Letter E, let's consider whether we can find A, R, or B. So a sample of carbon-14 has a mass of 100 grams. 100 grams is what we start with. Carbon-14 is just the name. Okay. It has a half-life every hour. So half-life, that's when we know what B is. So B is 0.5. Okay. Develop an exponential model that represents the mass of carbon-14 after a given amount of time. So then for R, they didn't give us an R value. So we don't have to worry about R in this example. Now you have A and B. You should be good to go to write your equation. On letter E, you start a job with a salary of $74,000. That's your initial value. Your contract states that you will get a raise. That means it's going up, so that's going to be a growth of 1.5% each year. Now turn that into a decimal for your R value. Okay. Now write the function to determine the salary after a given number of years since you started the position. So for B, because it's a growth, we're going to do 1 plus 0.015. Okay. So the pieces that I'm going to need to write the equation are going to be the A value and the B value. Make sure that when you do B, you add those two numbers together. Don't leave it 1 plus 0.015. Actually add them together so it's 1.015. All right, so if you finish the backside of this worksheet, get it uploaded to Canvas for extra credit. And then I look forward to seeing you guys on Monday.